Hi, my name is Peter Loddengaard, and for my senior project, I created a user-friendly wine collection inventory management system, and my technical advisor was Dr. Reza Faragabagher. During this presentation, I'll take you through my problem statement, the scope of the project, my experience with Ruby on Rails, the form-filling ergonomics experiment that I performed, the statistical analysis that went along with that experiment, the interpretation of those results, and we'll finish off with an economic justification of the system. Now I'll give you a moment to read over the problem statement for this project. And this is a summary of some of the frustrations that a lot of wine collectors feel when they're trying to keep track of their collections. For this project, I created my system with the software Ruby on Rails. Because I was learning a new type of software, I had to narrow my scope a little bit. I kept the inventory viewing page relatively minimal, while the focus was on the wine bottle entry forms. This is because many users stop using these types of inventory systems because the entry process is too tedious. This led me to coming up with an ergonomic experiment for those entry forms, which allows me to tie in the industrial engineering principles that I've learned here at Cal Poly. Now I'm going to take this time to show you a little bit of my system. This is the inventory viewing page that I mentioned earlier, and as I said, I kept it relatively minimal. Across the top, you can see a table that will show you your collection value at purchase, your current collection value, and the total number of bottles in your collection. And the second table is the bottles themselves, and you can see the different categories, and if you click the headers, it will sort them. And after I discuss my experience with Ruby on Rails and the ergonomic experiment that I came up with, I'll show you the entry forms that I created as well. While learning Ruby on Rails, I encountered quite a few challenges. For one, I not only had to learn Ruby, but also a little bit of HTML, CSS, and JavaScript to help it enhance my design. Also, since none of the Cal Poly industrial engineering professors have experience with Ruby on Rails, I had to enlist the help of my brother who's a software engineer, and this required a lot of time on the phone and on video conferencing and those types of things. Because as a beginner coder, I needed help with certain things like setting up the environment to code in and some of the syntax differences from the software that I'm familiar with, which is Visual Basic. Despite these challenges, I thought learning Ruby on Rails was a really good experience because I got to learn a new programming language and I got to learn to combine some of my industrial engineering skills with some new software skills. Now let's go over my experiment. I ended up coming up with 4 forms. 2 forms had the ergonomic F-shape layout, one with autocomplete and one without autocomplete. And then the second 2 forms had a simple vertical text box layout with autocomplete and without autocomplete. I will show you these forms after this slide. My experiment was performed in the IME Ergonomics Lab on February 18th and 19th between 10 a.m. and 2 p.m., and my sample size consisted of 40 Cal Poly males. Ideally, my sample would have consisted of wealthier, middle-aged men and women who collect wine, but for the scope of this project, I had to stick with who I had access to, and I only picked males because it would make my statistical analysis a little simpler with only one factor. Also, I made sure that the subjects had never used any wine inventory software to keep the experiment unbiased. The final component of the experiment was a questionnaire where the users rated from 1 to 5 their overall experience, the layout, the overall appearance, and the user-friendliness of the forms. Now let's take a look at the task that the user had to complete. You can see on this form that the text boxes have autocomplete, meaning that the user only has to type a couple letters before the rest of the word can be filled in automatically. Also, the text boxes are laid out in the ergonomic F shape that I mentioned earlier. Here you can see one of the other four forms, and this one has the vertical text boxes, so no F shape, and also no autocomplete. After collecting my data, I ran a few different statistical tests. First, I ran a one-way ANOVA test that showed that it was plausible that there was a statistically significant difference between the forms. The ANOVA was followed up with a Fisher comparison test that revealed that Form 3, the one with no F-shape and no autofill, had the lowest completion time mean. Next, to analyze the data received from the user questionnaires, which rated overall appearance, overall experience, layout, and user-friendliness, a Kruskal-Wallis test was performed. This test revealed that only Form 1, which was the form with the F shape and no autocomplete, was rated significantly lower than the other forms in only the layout category. In all the other categories, the median ratings of the forms were essentially the same. Finally, I tested to see if there was a correlation between overall experience ratings and entry times, and it turned out that there was a weak correlation between high overall experience ratings and low entry times, but this correlation was not statistically significant. Although the statistics revealed that the simplest form, the one with no autocomplete and no F-shape, was the most user-friendly in terms of entry time, there might be some reasons as to why the autocomplete and F-shape weren't quite as effective as expected. For instance, many of the users ignored the autocomplete function altogether. Many of them stated after the experiment that they thought that they weren't supposed to use it, and that it was the last user's entry, not a built-in autocomplete function. Also, some users used Tab to get to the next text box, while some users used the mouse to click to the other boxes. Finally, some users stated that the F shape was confusing because while the form was in the shape of an F, the attributes that they were supposed to fill in for the experiment were listed vertically. These factors could have contributed to the high standard deviation that was seen in the F layout forms, and also this could reflect the lower layout rating that the F shape received. It's possible that if the users were told beforehand that they could use Tab and autocomplete, the results would have been different. And now, to finish off the presentation, I'll take you through an economic justification from the perspective of a wine collector. I chose to focus on the user because most of the wine collection software out there is free, so I think it is important for collectors to understand how much money they could be losing from poor inventory management. Since wine bottles can range from tens of dollars to thousands of dollars, and collections can range from tens of bottles to thousands of bottles, it is difficult to come up with averages for collectors. Because of this, I have laid out two possible scenarios for collectors. Here you can see in a conservative example, if every collector worldwide only lost 5 bottles per year due to poor inventory management, and the average cost of bottles in those collections was $150, each collector would lose $750 per year, meaning over $650 million lost per year worldwide. In a more liberal example, if every collector worldwide only lost 10 bottles per year due to poor inventory management, and the average cost of bottles in those collections was $250, each collector would lose $2,500 per year, meaning over $2 billion lost per year worldwide. Ultimately, a collector is not going to continually use inventory software that is tedious to use, considering the volume of bottles that some collectors have. This means that it is very important to create software that is user-friendly because, as seen in this economic justification, a lot of money and wine could be at stake if your wine inventory is poorly managed. I really appreciate you taking the time to watch my presentation, and if you have any questions for me, feel free to contact me at the email address that I have listed. Thank you.